This video covers mean absolute deviation. This is the third measure of variance besides range and interquartile range. So at the beginning of this unit, we talked about the three measures of central tendency, which were the mean, the median, and the mode. And then we talked about the three measures of variance, well, two measures of variance, right? In elementary school, you all learned the first measure of variance, which is the range. Earlier we talked about a better version of the range, or the interquartile range. And now today we're going to talk about the last measure of variance, which is the mean absolute deviation. Most of my students by mid-year or the end of the year forget how to find mean absolute deviation. And when they ask me, I'm a jerk and I tell them, well, it's in the name. To find the mean absolute deviation, you literally find the mean of the absolute deviations. And then they inevitably ask me, how do I find absolute deviations? And I tell them, oh, sorry, that I cannot tell you because we're taking a test right now. So hopefully you don't forget this. Okay, to find the mean absolute deviation, you must first find the mean of your data. Okay, just like how IQR is related to median, right? To find IQR, you have to find median. To find the mean absolute deviation, you have to find the mean of your data first. So what is the mean of this data? Let's look at number one. So the mean would be what? 32.25 to 2 and 18. I'm just going to add that to 20. 1 plus 5 is 6, plus 7 is 13, 19, 23. Okay, so that all adds up to be, let's see, 7, 10, yay. 4, 5, 6, 7, 8, 9, oh, 100 exactly, okay. Adds up to 100, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 10. 100 divided by 10 is equal to 10. So the mean is equal to 10. All right, I'm done with number one. I found the mean. Number two, again, this step can be skipped later on. I'm only doing this step once, and then the other two practice problems later in this video, I'm going to skip it. I'm going to find the absolute deviations of your data. So what that means is deviation is how far your number is away from the mean, okay? A deviation is how far your number is away from the mean. So 32 has a deviation of 22 because it's 22 units higher than the mean of 10. 25 has a deviation of 15. 2 has a deviation of -8 because it's 8 smaller than 10. 18 has a deviation of +8 because it's 8 bigger than 10. 1 has a deviation of -9 because it's 9 less than 10. 0 has a deviation of -10. 5 has a deviation of -5 because it's 5 less than 10. 7 has a deviation of -3 because it's 3 less than 10. 6 has a deviation of -4 because it's 4 less than 10, and 4 has a deviation of -6. So this step is honestly skippable, but I'm just doing it to explain what deviations are. All right, deviations are how far your number is away from the mean. Right, like for example, 0 is 10 less than the mean. 6 is 4 less than the mean. 25 is 15 more than the mean. Okay, so this step we'll skip because we'll go straight to absolute deviations. Absolute deviations, like absolute value, is just the positive version, right? It's how far your number is away. It doesn't care whether it's greater than or smaller than the mean. It's just how far away is it. So the absolute deviations are just all these numbers, but positive. So our absolute deviations are 22, 15, 8, 8, 9, 10, 5, 3, 4, and 6. Because 32 is 22 units away, 25 is 15 units away, 2 is 8 units away, 18 is also 8 units away, right? Both 2 and 18 are 8 units away from 10, right? 2 is 8 units less than, 18 is 8 units more than, but to find absolute deviations, it doesn't matter, right? It's just 8 units away from 10. So these are the deviations. I should probably label that. Deviations. And then here we have our absolute deviations. So again, generally we can, once you're good at this, we can skip the deviations, right? We can go straight to absolute deviations. So step 1, find the mean. Skip step 2, go straight to step 3, find the absolute deviations, how far every number is away from the mean. So these are absolute deviations. Now to find the mean of your absolute deviations, we need to add them up and divide by 10 because there's 10 absolute deviations here, right? So we add them up and divide by 10. So, oh man, adding this up, let's see. These two will be 30. These two will be 23. You got a 19, 8, and 10. 53, 27, and then scroll down a bit, 37, 8, 90, so 90. So the sum of all the absolute deviations is 90, and 90, since there are 10 absolute deviations, divided by 10, so that's going to be 9. Our mean absolute deviation is equal to 9. So again, this is a measure of variance. This tells us if it's bigger, then the numbers are more spread apart. If the MAD is small, then the numbers are close together. Okay, next example, find the MAD. So again, I have to first find the mean, right? So 31 and 28 adds up to 59. 30 and 30 is 30 plus 30 plus 31 is 91. Add this up, get 10, 1, 15. 150 divided by 5. Divided by 5 is 30. Okay, so the average is 30. So the mean is 30. Next, we find our absolute deviations. Again, I'm skipping the deviation step. I'm going straight to absolute deviations. 31 is 1 unit away. 28 is 2 units away. 30 is 0 units away. 31 is 1 unit away. 30 is 0 units away. So I have 5 absolute deviations. Now I find the mean of the 5 absolute deviations. So 1 plus 2 plus 1, what is that? It's 4. Divided by, so this is the sum, divided by, there's 5 absolute deviations. So 0.8 or just 4/5. So the mean absolute deviation here is 0.8 or 4/5. All right, last one. Again, step 1, first find the mean. To find the MAD, we have to first find the mean. 70 plus 68, that is 138. 70 plus 72 is 142. 68 plus 66 is 120, 134. Add this all up, that's 14, 4, 8, 11, 440, oh god, I hope that's right. 1, 2, 3, 4, 5, 6. Okay, so 414 divided by 6. 6 times 6 is 36. Subtract. I get 5. Bring down the 48. Whole number 6 goes into 54 exactly 9 times. Nice. Okay, so we have a mean of 69. Then we find absolute deviations. 70 is 1 away, 68 is also 1 away, 70 is 1 away, 72 is 3 away, 68 is 1 away, and 66 is 3 away. So we have 6 absolute deviations. Now we need to find the mean of these absolute deviations. 1 plus 1 plus 1 is 3, plus 3 is 6, plus 3 is 9, plus 1 is 10. Oh, 10. So the sum adds up to be 10. Is that right? Yeah, divided by 1, 2, 3, 4, 5, 6. Oh man, that's gross. 10 over 6, to simplify that to 5 over 3. So our MAD is what, 1 2/3 or 1.6 repeating. as our mean of the absolute deviations. All right, that's all.